always have like the development or the software skills to really build something. So this is where some nice people of Geeks Up gonna help the participants out a little bit. And then in the fourth week, we are the participants going to refine their business model, because in the third week they actually build something so they can test it with our potential customers. Is this really going to work? So there we're really going to try and test like how to refine the business model, how to make it better. And then last week there won't be a program, because then it's going to be then the teams are really like self-sustaining and they are really a startup team. But the only thing is that they have to prepare for the final pitches, because the final pitches will be the last day of the course, where they're going to pitch, all the participants, their teams are going to pitch for a jury. And this jury consists of the local ecosystem accelerators and incubators, such as Demium, Business Booster, and also Geeks Hub will be in the jury of the final pitches, which can, of course, give a lot of valuable feedback to all the participants, how they actually done and how they present their own business idea. Of course, we have also some coaches or inspirators. For example, Iker Makaide, and I guess you know him. He's like the startup guru of here in Valencia, and he will be like all the other guys will available to speak to the participants, and also be available for the participants that they can ask like any questions they have. And furthermore, I introduce you Christoph. He's on the bottom left, and he is the founder of Decentralised Labs, and he's from Austria, and he's going to give like a property. So that's about the 5. So yeah, like I said, we don't ask for money for the participants. The only thing that we ask is really full commitment, you know, because how the human brain sometimes work is that if something's for free, then you value it a little bit less, and then you won't be committed anymore to what you do. So what we really ask for our participants, that they like fully committed to what they do, and that they stay with us like for the full 5 weeks. So what we do is exactly like 2 to 4 hours or 6 hours of group sessions every day, and the rest of the day you work together with your team on the business ideas. And especially at the end of the 5 weeks, it's more or less teamwork, because then you become a real startup. Yeah. So let me skip this one. Yeah, and now we're really busy at the final stages, because we're really gonna start like this Monday on this course. So yeah, are attending the course, which is really nice, of course, because this is what we also aimed for. So really doing, we have a second course starting in November. Yeah, so this was a short presentation about Decentralised Labs. So if you want to follow us, or you can search on Facebook, or you can email me, or we can talk a little bit after this session or whatever, you can contact me. So yeah, thank you very much. Any questions?
Yeah. What is the business model of it?
Yeah, the business model is a good one, because of course we are non-profit, and what we ask for, like when we started, is just we only live on donations and subsidies, and the rest, if we can't afford it, we pay out of our own funds. So there's no strings attached or something. We don't ask for equity or for any fees or whatever. So yeah, you can say it's not really sustaining business model. I agree, but yeah, we will see. We're gonna evaluate after also the second page how it was and how we stand. Any more questions? All right. Well, thank you. Thanks.
Bueno, pongo un poco al día de todo lo que ha pasado las últimas 16 horas con la charla de Augur. Perry no ha podido coger un tren, Perry es una charla, y ya un poco tarde, con lo cual lo que nos ha hecho es su lead developer ya estará con Skype, en conferencia con nosotros, nos contará una pequeña presentación tecnológica del proyecto, qué proyecto tiene Augur, cómo está hecho, y a partir de ahí pues será algo bastante más interactivo donde podemos hacerle preguntas y nos contará más detallado lo que queramos saber. En ese sentido, pues la charla tiene una duración que más o menos, y ahí ya pues eso será el mitad de hoy. Voy a ver, llamarle.
Hello.
Hi, Jack.
Hey, can you?
Well,
Yes, are you David?
Yes. Nice to meet you.
Nice to meet you.
Well, we are. JavaScript community.
Okay. Hello. Hello.
The goal, Augur.
Can you guys hear me? Okay. I think my connection's a little choppy.
We see you.
Hang on. Let me try and plug in my Ethernet cable. I'm on wireless right now.
Oh yeah, we have a
Give me 1 second.
video problem.
We'll see if that speed things up a bit. A few words about Augur to off.
Sí, está realizando algo porque tenía problemas.
Sí, parece, bueno, ha tenido un problema con internet, lo he dicho antes de cortar. Así que.
Muy bien.
Estoy pulsando el botón de llamar en la pantalla.
¿Es aquí? ¿Puede ser?
Sería un botón de llamar. Haz la ventana pequeñita. Ahí arriba. A ver si la pueden enganchar aquí o. El de más es solamente lo que hiciera. Sí,
Ah, sí, sí.
ya le he hecho el vídeo. Ya está. Hi, Terry.
Hey, can you guys see and hear me?
Yes.
A ver, creo que ahora sí.
Un momento. Voy a poner yo.
Ya, creo que se escucha normal. A ver cómo se escribe aquí.
Ahí.
Okay, just yeah, let me know when we should start.
Joder, no está. Lo dejo así, ¿no? Ahora.
Terry, Gas, do you hear me?
Yes, I can hear you.
Okay. Welcome to our meetup, Untitled Chapter. Well, you are the lead developer of Augur. You can say a little words of Augur at the presentation.
Yeah. Well, so first of all, thanks for inviting me. And my partner Perry was supposed to be here and give, I think, more of a presentation. So I don't have any slides prepared or anything like that. But I'll just say a few words about Augur. First of all, can everybody hear me? Okay.
Yes.
All right. I'm hoping silence. Hoping silence means yes. So Augur. So I'm not sure if you guys have had previous exposure to Augur. Basically, we are building a decentralized prediction market platform. So I should say a couple words about what prediction markets are. Basically, it's a market where you can bet on the outcome of an event. So the example that we like to use is an election, and you can bet that you will or bet that you won't. Now if Hillary does win, then the price of a share of Hillary winning is $1, and if she doesn't win, it's 0. So if the current price of the prediction market is, say, 42, then that means that the quote-unquote wisdom of the crowd it says that, yeah, sorry, what?
We have
Yes.
problems. I need the video.
You're having problems with the video?
Sí. And the audio, a ver.
Okay.
Okay, try to talk now.
Okay. Yeah, I can just keep the video on.
Okay, continue.
Can you guys hear me better? Okay. So if the price of a share in a prediction market of, say, Hillary Clinton will win the election is 42 cents, then that means that the crowd, people putting
sorry.
Yes.
From the start, I think we can help you most of the time.
Okay.
Sorry.
You guys want to try Google Hangouts? I find that the connection is better with them sometimes. Okay, you guys probably couldn't hear that.
One moment.
Además, Fernando, en el Hangouts le quitas el micro. No sé, igual si ya se corta y ya no se oye. Lo que te decía es el ancho de banda, sino que oye un ruido.
¿Me la has pasado, puede ser? ¿Está por ahí? ¿Ha pasado el enlace?
Paso antes.
Sí, pero me pasó. ¿Hay que poner nuevo link? Sí.
Pantalla.
Que me trolea porque sale esto, entro y Cali me dice que ya estoy ahí. Que no la termino porque técnicamente estamos en la otra.
Te lleva ahí y te abre eso de ahí.
Sí, pero es que no sale él, tampoco me ha dicho nada.
Esperando a los participantes. Cuando abra el link, entonces saldrá él.
Sí, pero el tema es...
Hey guys.
¿Él ha entrado?
Sí.
Pero aquí no le vemos.
Okay, now my sound's messed up.
Como me la liáis, pues ahora tengo que cambiar todo.
¿Cuál le ponemos entonces? El allí.
Sí.
Hey, can you guys hear me? Hey, can you guys hear me? Yes. Hi.
Okay, we are configuring the system.
Okay.
Okay, perfect. ¿Tiene más volumen esta? We are we are putting the sound in one moment.
Okay. Can you guys hear me better now?
Repeat.
Okay. Should I go ahead and start? Can you guys hear me?
Yes. One moment.
Okay. Yeah. No problem.
Sorry for that.
No. You're fine.
Okay. You can.
Okay. Should I go ahead and start?
Yes, a ver, ya hemos configurado todo otra vez. Bueno, muchas gracias por la paciencia. Jack, you can start.
Okay. So I'm not sure how much of what I said before you guys got, because I know we're having connection problems. So Augur, we're building a decentralized prediction market, and prediction markets are basically markets where you can bet on the outcomes of events. So the example I like to use is an election. So for example, will Hillary Clinton win the 2016 US presidential election is one example. And you can bet yes or no. And if she ends up winning, then the price of a share of yes is $1 per share. Can you guys still hear me? Okay, the video is a little choppy. And if she ends up losing, then the price of a share is $0. And so if the current price is, say, 42 cents per share, what that means is that she has a 42% chance of winning. And that's sort of her market price of winning. So it's like people putting their money where their mouth is, so to speak, have in the aggregate said that she has about a 42% chance of winning. And if you have a fairly liquid market with a lot of participants, it turns out that that's a reasonably accurate estimate of the actual chance that she has of winning. Now, so prediction markets are a very general idea. That's one of the reasons that they're kind of cool, is because a lot of other kinds of markets or betting markets that you might be familiar with are specific kinds of prediction markets, and as such they can be built on our platform. So for example, who will win the Super Bowl? That's a prediction market, right? You're making a prediction. And another example is, will the stock price of IBM rise above X dollars on Y date, right? So an option is really just a kind of prediction when you think about it. And really almost any kind of market that doesn't involve like a physical good or service being purchased is really a sort of prediction market. And the way Augur is implemented is as a a set of smart contracts on Ethereum's decentralized network. So I should say first, the reason that we wanted to decentralize Augur is because there have been a number of problems with prediction markets that people have made previously that just existed on regular websites. So, I mean, the most obvious, if you're going to build a prediction market, the most obvious way to do it would just be to have, a regular website with, a regular, like an SQL database behind it. And, you would avoid a lot of the hassles associated with creating a decentralized network. But there's a few problems with that. One is that probably the biggest one is that if you have a prediction market or really any kind of market on a website, you have to trust the operator of the website. In this case, you have to trust somebody to do two things. You have to trust them to one, not raid the piggy bank. So you have to trust that they're not going to steal the money. And two, you have to trust them to resolve events correctly, right? So after the election, you have to trust that they'll actually say that the correct person, say whoever won actually won. And both of those have been problems in real prediction markets. And those are things that decentralization helps us get around. So we, let's see, can you guys, there's, my screen sort of just went dark. Maybe they just turned out the lights there. Okay, so we were originally going to build Augur sort of on top of Bitcoin, not in the sense of building on top of their blockchain. We require sort of too much functionality for that, but we were going to extend Bitcoin Core source code. In the process of sort of sketching out how we were going to do that, we realized that the kinds of Bitcoin's input-output style transactions that you have to make in order to make all the functionality required by a prediction market is actually pretty silly. You end up with some pretty crazy looking transactions. And essentially it amounts to an entire rewrite of Bitcoin Core. And well, I guess this is the JavaScript, not the C++ meetup, but the Bitcoin Core, it's not a fun code base to work with. It's fairly tightly coupled. It's like, probably 2/3 or more of its functionality is in like a giant file just called main.cpp. And if you change one thing, you have to change 10 other things. Around that time, the first really usable versions of Ethereum's software were coming out. And we were in contact with Ethereum's founder of Vitalik, and we talked to him a lot about the technology. And long story short, we were really impressed by Vitalik and his team, and we decided that would almost certainly be a faster way to get a version of this out there that people could actually use. And ultimately it would be a lot more versatile and would be part of this nice decentralized ecosystem. So and the way we ended up building it is we have a set of these what are called smart contracts, and that's basically just a fancy way of saying you have this decentralized network and people can put programs out on that network that are usable by people that are on the network. And the contracts can interact with each other in basically whatever ways that you want them to. And so we have those up and running, and we actually have an alpha version of our software available at client.augur.net. You can run it in sort of fully decentralized mode. If you're running a full Ethereum node locally, it will automatically detect it and start talking to it. What we found is that that's a headache for a lot of people to have to download and install an Ethereum node. So if you're not running an Ethereum node, it will just talk to our hosted nodes. So we have 5 Ethereum nodes spread around the world. Actually, we don't have one in Europe yet, but we probably should get one. So it'll just start talking to those, and yeah, what I'm specifically working on is I'm working on the front end code, the client, and I also have done the networking code. So like all of the way we actually call functions on these smart contracts on Ethereum is using JSON RPC. I don't know if you guys are familiar with that. RPC is just a remote. Are you guys still there? I think the video just cut out.
Yes.
Okay, yeah. So RPC is just a remote procedure call, and basically it's just a way of sending instructions to the Ethereum node over HTTP. So you send an HTTP request that sends a response that has whatever the response of the function was in the network. And so there's a lot of challenges associated with that. Like the first iteration of our client, we were just sort of brute forcing the communication with our remote Ethereum nodes. So all this is happening in the browser, and we would have the browser send like an AJAX JSON RPC request to the Ethereum nodes.
Oh.
And the problem with that is that in order to get all the information we need for the UI, there's we have a bunch of different markets and just a lot of other information about sort of the current state of our system. And it amounted to just a ridiculous number of RPC requests. Like we were sending like upwards of 3,000 RPC requests. And as a result, if you're sending those to a node that's in Tokyo or something, then you could easily wait 20 minutes for it to load. Now that's not usable if your users have to sit there for 20 minutes while your interface loads. Now it's a little faster if you're running an Ethereum node locally, but a lot of people don't want to do that. And so what we ended up doing is we thought, well, this hosted solution it's intended to sort of allow people to use it without having to go like full on decentralized, and it itself is not really a decentralized solution. It's compatible with it in the sense that the way that we allow people to use it is we have an account system, which is it's set up. I think a lot of web account systems are set up this way, but it's set up a lot like sort of a blockchain.info style wallet where we don't have access to any of our users, like any of our users' information. All we have is their encrypted key, which is decrypted with a password that they provide. And that key is actually is used directly in Ethereum. So it actually can be exported from our software and used on a local Ethereum node if the user wants. So it sort of preserves the spirit of decentralization in that sense. You don't have to trust us as the people operating the host. So it's trustless in that sense. And because it's not completely decentralized, we thought, well, we're hosting it anyways, so why don't we just have a process that runs on the server, and it grabs, it does these several thousand RPC requests. It can just do them on the server where it'll be faster, then it can store it, right? So we don't have to do it once and then update it however much we need. So we ended up we now have a process that runs on all of our servers, and it pulls the information off of the Ethereum blockchain, and it puts it in a MongoDB, and we have a REST API for that. So now it's just one remote HTTP request. So it's like the same amount of like the actual data in the body of the request, but as you can imagine, it's a lot faster to just do that once rather than several thousand times. So if you go to client.augur.net, that's why it loads. It doesn't take like 30 minutes to load. So,
Jack.
Yes.
Just one thing to put you into context. I know what is Ethereum, but maybe people here, how many of you know what is Ethereum? Almost nobody knows what is Ethereum. So the point it is, you are talking about the technical things, and I agree with you that having a Ethereum node is complex and has you need a lot of resources. So maybe you should explain a little bit in a more functional way, not such a technical. So we know what is an oracle, what is a prediction, what are the inputs, but not in such a low level.
Oh, sure. Sorry. So Ethereum is. Okay, so I guess I should ask first. Like, is everybody there more or less familiar with what Bitcoin is? So I'll start from that. Like, so if you're familiar with Bitcoin, Ethereum it's decentralized in the same way that Bitcoin is. It's a blockchain, and it's this which is just this sort of basic idea that you have basically this fancy shared database that enforces transaction ordering for you. And Ethereum, what makes Ethereum different than Bitcoin is that it's programmable. So on Bitcoin is essentially it's decentralized software, and really the only thing that it's meant to do is store and transfer value, right, represented by Bitcoins, and you can send them between users on the network. And there, of course there's other machinery associated with the network itself, like the mining and so forth. But basically, it's a store of value. And Ethereum it's the same basic setup, except now you have these extra things you can make. So there's still a currency. It's called, the internal currency for Ethereum is called Ether. And that functions a lot, very similarly to the way Bitcoin functions. It's a store of value. The thing that makes Ethereum different is that there are also these what are called smart contracts. And what smart contracts are, they're just programs on this decentralized blockchain network that can be invoked by people using the network. And the contracts can also call each other. And so that at sort of the view from 30,000 feet, that's basically what Ethereum is. And as you can imagine, there's a million little details associated with that. But basically, the more technical challenge that I was describing before was just that if you have data that's stored in Ethereum's blockchain, this is a shared database. It's not always stored in a way that is easy and fast to access from a website. Like if we have 500 markets or something in the alpha version of our software right now, just that our users have made, and those information about those markets is stored. It's scattered through different contracts, and so it requires quite a few requests to the blockchain to actually retrieve that information. And we're actually probably the first group that's really bumping up against issues like this, which are really just sort of networking / performance issues, because while there are some other applications that are being built on Ethereum, they're all relatively straightforward things, like block explorers and so forth. And yeah, so this is something that's sort of an order of magnitude more complicated. So we're bumping up against these performance issues. So does it? I guess I should stop and say, does anybody have questions about Ethereum? Does that all kind of make sense? So the basic issue is just that. So there's two basic parts to the system. There's the smart contracts themselves, which are these programs that are sort of floating out on this decentralized network. And these programs have functions, and they have all the functions required to make a prediction market. And they can also, I should say, they can also store data. So they do all that. And the other part of the equation is that we have to access all that stuff somehow from some kind of interface that people can actually use. for example, a website is what we're doing. And so that's where all this, the other sort of more traditional client server style networking stuff comes in. Does anybody have any questions?
Questions?
Okay, Jack. I think people now understands a little bit Ethereum. So, in the prediction market that you are building, you have inputs, and those inputs, on one way, it is the people that is betting on some event, and on the other hand, there is some kind of information. So, for instance, I say that it is going to happen something. I can check through a HTTP request and get this information. So your Oracle decides if it is white or black. Or you understand my question?
So one sort of fundamental piece of the system that I haven't talked about yet is the Oracle. So what I mean when I say Oracle is it's basically this problem that, so say the event we're interested in is an election. So after an election, it's really obvious to any of us out here in the world who actually won the election, right? Like after the election's been run, you can, I mean, if you don't know for some reason, you can just like go into Google and you can look it up, and it's very straightforward. After the election, there's usually not, ongoing, uncertainty about who won. And the challenge is, how do you get that kind of information into the blockchain or just into a computer system in general? So there's a number of ways that you could think of doing it. We chose what we thought was maybe the simplest way, which is, well, we'll just ask people, hey, what actually happened? Who actually won the election? And we've set up a system of incentives to make sure that it should always be the easiest and most profitable option for people to simply report on the outcomes of events honestly. And I can go into more detail on that, but the key element for this quote unquote reporting system is reputation, or what we call reputation. These are so reputation tokens are something that are unique to our system, and they're what's used to report on the outcomes of events. So so for example, if I have one token and one of you has 2 tokens, then your report on what happened on, say, who actually won the election counts twice as much as mine, right? So it's not one man, one vote, it's one token, one vote. And that's basically just so we don't want people to be able to just create, dummy accounts and sort of flood the system with bad votes, right? So it has to cost some resource to vote. So we do one token, one vote, and those reputation tokens are actually the things that we're sort of auctioning off in our crowd sale, which is still going on right now and actually ends tomorrow. And so one thing you might be thinking is like, that seems like work. The people who have the reputation tokens actually have to do something. We're asking something of them. And that's true. And so every time, so right now we have the network sort of checking in with reality once every 8 weeks. And when it does that, people who hold reputation tokens have to report on what happened. And as consideration for the time and the effort that they spend doing that, people that hold the reputation tokens get half of the trading fees that pass through the markets. Now, these trading fees are not set by us. They're set by the person who creates the market. And they can be just about anything. And the person who creates the market gets the other half of the trading fees. And the reason that they get the other half is they provide a certain amount of initial liquidity to kick off trading. And the people who report on the event to resolve it get the other half. So this is, you can see this is something that would, initially it will be, probably just a trivial token amount of money that's coming through the markets to the reputation token holders. But it's something that should scale pretty well. So you know, how well they do will end up. You know, if the network does well, then token holders will do well, which seems appropriate.
Bueno.
Me again. Sorry for asking so much.
Oh no, it's fine.
Another question about legal issues. If I see from Eagle view Augur, I can use for many purposes. So, for instance, I can bet who's going to win that match. So, for instance, in Spain, if you have some kind of bettings, you need a license, a gaming license. So, how does it match this with Augur product?
That's a good and actually very important question. That's something that we've thought about a lot. And the key thing for us is that we don't, like, we as the people making Augur, we don't make markets, or we won't make markets on the real money system once it's out, and we won't bet on them. So our only role is making this platform, this software that people can use to make markets. So we don't make the markets, we don't bet on them, we're just writing software. And so we say that, you know, Augur it's decentralized and it's a global platform, right? So there's now prediction markets are the legal issues surrounding prediction markets are different in different places, and there's different kinds of laws surrounding various kinds of betting, for example, like a sports match. So I live in Oregon in the United States, and I think it actually would not be legal for me to make a market on a sports match. So it's up to our users to make sure that what they want to do, whether it's place a bet or create a market, is legal where they're living. Because even if we were inclined to do this, we wouldn't be able to make sure that our software is automatically, you know, compliant with the laws wherever you live, right? Because it's decentralized. So the burden of that is really on the user. And yeah, so that's the main thing.
Okay. Well, we have a bit of time from 18:30. If anybody wants to question, or
Yeah, no, I mean, keep hitting me. It's cool.
It's me again. We will do another meetup. We have a Bitcoin association here in Valencia, so I will contact you. So
okay,
my last question. My last question. Yes, how do you compare Augur with other prediction systems like Trustcoin? I mean, I know that Trustcoin is a sidechain of Bitcoin, and you are based on Ethereum. But from the business point of view or functionality, there is something that you want to highlight.
Yeah, I mean, so I guess this sounds a little flippant when I say it this way, but the biggest distinction between us and Truthcoin, which is sort of a thematically similar system, is that like our software actually exists, and you know, we'll be very interested to see how their system works when they have working software, and until they do, I feel like it's you know, it's hard to say, like, because it's sort of hypothetical how Truthcoin would work. Yeah, so Truthcoin is it's also a decentralized prediction market system. It's being built using Bitcoin Core source code, so they're actually going a route that's similar to what we were originally looking at, and they're also, and their implementation plan is as a Bitcoin sidechain. Now that part's actually not different, because we do intend to ultimately sidechain to Bitcoin. And I guess without going into too much detail about what that means, basically it's just when the technology is available, we want people to be able to use Bitcoins directly in our system. That functionality very likely will not be available when we do our beta, or probably even our full release. So our beta is, we're shooting for around Christmas, and the full release will be sometime in the spring. And I've heard different estimates for when the different versions of sidechains will be available, but it looks like they're probably farther off than that. And the only other, and so the other, sort of competitor on the horizon, at least that we're aware of, is a prediction market also on Ethereum called Group Gnosis, or Gnosis, I actually don't know how to pronounce it. So they have distributed custody of funds. So the funds that are used on their prediction markets are they're on the Ethereum network. So they have that sort of trustless aspect to it. I think the most significant way that they're different from us is that they don't have decentralized event resolution. So I know right now their system is actually fairly similar to the way that the old prediction market websites worked, where the operator of the website would just determine what the event's outcome was. And I know that they have other methods of event resolutions planned, but I don't think they're doing anything that's really decentralized. So they're pretty different in that regard, and so I think we're sort of fundamentally different products.
Jack?
Yes.
Okay. Lose audio for a moment. Okay, all the questions asked for the Bitcoin. Augur is a big platform, has for example, the front end is with React. No?
I'm sorry?
The front end is with React, for example.
Sorry, you're kind of breaking up the front. Something about the front end. The front end is
the front end is with React. It's made with React.
Oh yeah. So the client. So one thing that I forgot to mention is all of this is open source. So if you go to github.com/Augur Project, we have a bunch of different repositories. It's all open source, and yeah, I guess this is a room full of JavaScript programmers. So like almost all the programming that we're doing right now is JavaScript, for better or for worse. And we certainly could, we'd be happy to have your help. So it's a combination of networking and sort of UI UX code. The UI is as David said, it's in React and Flux. So let's see, what is there to say about that? So what we have, I don't know if you guys are basically familiar with how React and Flux work, but basically we have we update the data stores. So the way that Flux is sort of like it's a set of data stores, and they will propagate changes to React and Flux together. Will propagate the changes to the actual DOM, so we have different kinds of listeners that listen for changes to the blockchain. And those update the Flux stores that sort of filters down to the actual React components. I'm not sure if that's the right kind of explanation. So are you guys? I guess I should just ask. Are you guys familiar with React and Flux, or some of you? Your video, I think, is cut out, so I can't see.
Hi, can you hear me?
Yes, I can hear you, but I can't see you.
Here.
Oh wait, now I can see you.
So I'm starting now with Angular and heard that React is some kind, in a better way, better than Angular for some things. So what made you choose React with Flux instead of Angular or any other JavaScript framework? Why should I choose React, for example, or made you choose?
So that's a good question, and so I feel like I should have a better answer than this. So I actually personally didn't make the selection of React, and we chose it basically because it was being used by EtherX, which is in a decentralized exchange being built on Ethereum. And at the time, we didn't really have a good sense of what the challenges were of, sort of plugging into the blockchain from a web application. And so we thought, well, sort of two heads are better than one. So we'll use the same set of technologies that EtherX is using. I guess the deeper answer is that we thought that the sort of observer pattern that Flux uses is a pretty good match for having to retrieve updates from a blockchain system, because like on Ethereum, the average block interval is 12 seconds. So that means that we should be able to pull in a full set, like a full block of changes every 12 seconds and, do that as kind of this atomic update. And so we only have to propagate changes to the DOM once. And our thinking was, well, that'll make it a lot more efficient. And it'll take advantage of the fact that in between block arrivals, there shouldn't be, there won't just be things like random changes streaming in, from some notification system. Things arrive in these sort of discrete chunks. So yeah, it was both of the things. Probably more the first thing than the second, if I'm going to be honest. But yeah, those were our reasons. And also, I haven't used Angular, so yeah, so I can't really do a good comparison with that. I have used Ember previously, and I personally I found it to be, I thought it was a little much. Like it was. And I guess React and Flux have an element of this too, but it almost feels like it's like you're not even writing JavaScript anymore. You're writing like the special Ember like domain specific language, which in Ember's case I wasn't too crazy about that language. And React and Flux is I think better in that regard.
Thanks.
Mm-hmm.
Any questions? Okay, sadly we don't have more time. And then
okay.
Thanks, Jack. Thanks.
Yeah.
No, thanks.
Yeah, no, thanks for listening, and yeah, it was really nice talking to all of you. And we have the way we do almost all of our day-to-day communication is Slack, and so yeah, I'll post a link. It's an open Slack, so if any of you guys are interested or think you might be interested in contributing or just want to take a look at the code, please just hop into our Slack channel, and you can ask us questions or sort of just monitor what we're doing. So yeah, but yeah, thanks for inviting me. It was really nice to meet all of you. You guys are frozen, I think, so I don't know if you can still hear me. Okay.
Okay, that's it.
Yeah, you guys froze for a minute there, but yeah, thanks for the invitation, and yeah, it was really nice to meet all of you.
Okay, bye-bye.
Okay, take care, guys.